Artur, it's very nice to have you here on this call today. As part of this series of interviews, we are getting to meet different editors that work in our journal, Chemical Engineering Research and Design. You have quite a special relevance because you are one of the newest editors who has joined the journal, and you have joined the process systems kind of part of the journal, but you represent this area of machine learning in chemical engineering. So you're both new to the journal and you're working in a relatively new discipline. So could you start by telling us a bit about yourself and maybe your background and where you're working now?
Yeah, of course, happy to do that. Thanks a lot for having me here. I'm Artur Schweidtmann. I studied mechanical engineering at RWTH Aachen University. I did my master in chemical engineering in Aachen as well. And I was very lucky because I could go abroad to Carnegie Mellon University during my bachelor for 9 months, learning more about process systems engineering.
Mm-hmm.
And I also spent some time at the University of Cambridge for my master's thesis.
So for someone, please continue. Yeah.
And now since April this year, I started as an assistant professor at University of Delft.
Great. So tell us a bit about your focus research area, because you are in this emerging field of machine learning and AI, and I guess that's part of what you're establishing there at Delft as well.
So my research is all about artificial intelligence and machine learning in chemical engineering. So I work a lot on how we can combine our mechanistic understanding in chemical engineering with the new data-driven approaches coming from the machine learning community, and also about how we can represent the knowledge and information we have in chemical engineering through new approaches such as knowledge graphs, for example.
That's very, very exciting stuff. I personally have quite an interest in this topic as well, and I am thrilled to see that we I think we're only really just starting to publish a few papers in this area in the journal, but I hope that you are handling some papers as an editor now in this area. So can you tell me, firstly, you're relatively new to working as an editor, so how have you found it so far?
Yeah, I just started as an editor at Chemical Engineering Research and Design this year. I very much like it. I'm handling basically manuscripts in the process systems engineering area, in particular with the focus on machine learning. And I found it very nice because I get to read a lot of new research articles very early, and also get quite a broad range of different articles, really covering the whole scope of research in chemical engineering as well.
Yeah. I'm sure many other editors would say that they're the same things that they like about working as an editor. Can you tell me in particular about machine learning in chemical engineering? What kind of topics do you see are likely to be published in the journal? Maybe something from your own research, or because for many readers and many people watching this video that are chemical engineers, they would have very, very little experience or exposure to this so far. So maybe could you explain maybe a classic implementation or some of the areas where machine learning is penetrating in chemical engineering?
Yeah, of course, I'm happy to do that. So in chemical engineering research and design, we actually cover a very broad range of chemical engineering applications, and we do the same for the machine learning field there. So what we see is basically we see a lot of articles which apply machine learning to chemical engineering process design, for example, or also process operation. So some papers are focusing more on the research aspect. Basically manuscripts are together with industry, actually dealing with operational data, for example. And we also see more and more manuscripts that also further develop machine learning methods specifically designed for chemical engineering applications.
Okay, that's interesting because I imagine so far most people have been taking already developed methods that have been developed for other applications, image recognition or language processing or other applications, and bringing them over and adapting them to chemical engineering applications. But what you're saying is that now people are starting to specifically develop methods tailored for chemical engineering applications. Is that right?
Absolutely, yes.
Yeah.
The interface of these two research fields is very, very important.
Okay.
Because we as chemical engineers have very specific needs for machine learning methods.
Mm-hmm.
And we also have a lot of mechanistic knowledge about our processes. And it's very important to combine both of these fields.
So I guess logically it makes sense that one of the, the first disciplines within chemical engineering to embrace machine learning is process systems engineering, because it was already a field that's, heavily reliant on computers. And then the operational side, I guess, comes more from the data perspective, right? Because this is an aspect of chemical engineering that generates large quantities of data. So machine learning and AI methods give new insights and ways to use that data, maybe even in real time. But do you have any insights on the future directions? For example, reaction engineering, reactor design, the biological aspects of chemical and biological engineering. Do you see machine learning going further in these other aspects of chemical engineering?
Yes, definitely. So we see machine learning emerging in almost all of these fields at the same time. And some of them are like further ahead of other fields for different reasons. But for example, in reaction engineering, we see an increasing amount of articles on automation of chemical reactors, for example, and then coupling these reactors with basically feedback loop machine learning algorithm that is designing new experiments in something that is referred to as self-optimizing reactors. And we see a similar trend in biotechnology, for example, whereas in biotech, we are also able to perform a large number of batch experiments at the same time. And there is really a challenge, how can we deal with this high throughput data that we can generate, and how can we design those experiments in a meaningful way?
Super. So I've got a very sort of practical question. So if an author is, they've written a paper, or they've got an idea that they want to write up as a paper to submit to our journal, Chemical Engineering Research and Design, that's targeting an application of machine learning, is there any differences to how they might have constructed this paper or prepared the kind of package that they're going to submit compared to a traditional paper that they would publish? And I'm thinking in terms of the code and the data.
Yeah, exactly. And that's a very good point. So in particular, I would like to encourage all authors of all journals in our domain to publish not only their manuscript, so the text, but also their data, the code, maybe some simulation files together with the manuscript.
Yeah.
Because that's essential for reproducibility of the results, for building on new methods based on previous publications. So I would highly recommend to publish your data, publish your code, publish your Aspen simulations, publish the files for your CFD simulations together with your data. So this is not only for machine learning articles, but in my view, it's very important, essential for all articles in our domain.
Yeah, I strongly agree with you. And I guess as a journal, we're quite agnostic. We're actually willing to accept all kinds of different repositories so long as they are open and findable and people can receive the data. So a Git repository for code would be perfectly fine, I take it?
Exactly.
Yeah, and then some other more data appropriate repository for large data sets.
Exactly. So many universities provide their own repositories for data. Mm-hmm. There's also public ones where you can get a URI, like a unique identifier for your data, which is persistent. So you get a guarantee that the data is also accessible in like 10, 15 years. And you can get also an DOI for your data package that you can cite with your research, that also other researchers can cite if they use your data.
That's obviously one of the benefits for authors as well, right? You know, if they're not just producing a manuscript, but they put the code and the data out there so that others can improve on that, they can compare their own calculations and simulations to that, it should actually increase the number of readers and increase the number of citations that they get to those papers.
Yeah, it does, definitely. And it will also accelerate the whole development process. Yeah. Because other people don't need to, re-implement everything from scratch.
Definitely. No, I see that as a big win-win for our authors and for our readers. Can you tell me a little bit about what you see as the benefit of our journal for people submitting, for example, machine learning papers? Because there are niche or specialist journals that publish in methods for machine learning, applications of machine learning. But when people publish with us, those papers get exposed to a very different kind of readership. So what do you see as the benefit for authors submitting their machine learning with relevance to chemical engineering research to us?
Yeah, so big advantage is basically that our readers are chemical engineers mostly, and very broad variety of chemical engineers. So if you have a new machine learning method, a new application of machine learning in chemical engineering, and you want chemical engineers from different disciplines to read it, I think that's the right journal to go.
Excellent. Yeah, I would strongly agree. So finally, can you tell us a little bit about the future directions, where you see your work going, where you see publishing in chemical engineering going? What's your vision for the future for this field of chemical engineering?
Yeah, thanks a lot for asking. So I believe we will, and we as researchers, and we as industry, as chemical engineers in general, we will see a huge transformation of the chemical engineering industry through machine learning and data in the future. And I believe we will also see a huge transformation of the whole publication process in chemical engineering and in research in general. Because at the moment, we still publish our publications in PDF format.
Yeah.
Many people don't publish their data with the manuscripts. I think we will see a rapid change of this publication process in the future. So people more and more publish the data with the manuscript. In the future, we will also see that people publish the results of their approaches in a more structured form. So other people can reuse it, can easily find it, search for it. And I believe we will see huge differences there.
So thank you very much for your time today, Artur. It's been really a pleasure to meet you as one of the newest editors in the journal, working in one of the emerging areas. You have a very interesting and international track record between Germany, the USA, the UK, and now your own position there in the Netherlands. We wish you every success in your research, but especially we're grateful for your contribution to the journal as an editor, and we look very much forward to continuing to work with you. Thank you for your time today.
Thanks a lot, Bradley.